Hello, my name is Court Shute. I am a Chime Specialist SA with AWS, and today I'm going to be talking to you about the AWS Communication Developer Services. So whether you're in healthcare, financial services, retail, whatever vertical you happen to be in, the Amazon Communication Developer Services can help you build faster, extend your existing apps, and simplify operations. So what are the Amazon Communication Developer Services? The first Amazon Communication Developer Service is Amazon Pinpoint. And what Amazon Pinpoint can do is it will let you send notifications with SMS, with email, with voice, and you can use these push notifications out and get analytics back to create campaigns, and you can even personalize these messages. So this is a great way to create any trigger-based communication can be used with Amazon Pinpoint to get the message out to your customer. The second piece that we would talk about is the Amazon Simple Email Service, or SES. So Amazon SES is a globally available and one of the largest providers of email services out there. We serve billions of emails every single day. You can use this to send transactional emails, so notifications that something has shipped. You can use this to send promotional marketing material out to your customers to let them know that we have a new product that you'd be really interested in. And you can use it even to send notifications to let you know that a job completed, that a report is ready, things like that. Amazon Simple Email Services also uses APIs, so you can send these programmatically. So you can use a trigger, an event that will send an email out for you. The final one is the Amazon Chime SDK. And the Amazon Chime SDK was launched in reInvent 2019. It grew out of the Amazon Chime app. These are separate services now, but they had kind of common roots, and they have separate roadmaps, and they're really separate and independent services now. What we found was customers had a hard time building WebRTC communications. So building that with all the stun servers and the turn servers is really difficult. So we created 3 pillars of the Amazon Chime SDK to help people build these types of things. So the first one of these is the media services, sometimes referred to as meetings. So what we do with this is we establish multi-party media sessions using WebRTC to support audio, video, and content share. All of this is done in real time, and we do kind of all the hard work for WebRTC for you. The second pillar of the Amazon Chime SDK is the phone integration. So we have the ability to hook into the PSTN, the publicly switched telephone network, and allow you to make inbound and outbound calls using a traditional SIP trunk. So nothing kind of different from what you may be able to get today. But we also allow you to build telephony applications, so programmable voice. And what programmable voice is the ability to hook into a Lambda during a phone call. And we'll get into this a lot more later. The third pillar in the Chime SDK is messaging. And what the messaging app is a highly scalable, persistent messaging that enables you to use the AWS AI ML workflows. And what's really interesting about this one is we think of it as messaging, and it's called messaging, but it's really just data, right? So we can send a data packet to 100,000 different people all at once, and it's persisted, and we control all of that back-end work for you. It's finely grained for builders, so that's what we're gonna offer up to you. Let's take a little deeper dive into the Chime SDK meetings. So Chime SDK meetings uses a JavaScript client SDK in order to create a UI for your participants. So think about, you could build a web page, you could build an iOS app, you could build an Android app, and we even have React components that you can use to further speed up the development of this. And then we take those UI and we take the other UI and get them to talk to each other. So this is how we establish we can go from one-on-one communication between 2 participants, or we can go up to hundreds of participants in the same meeting. And all of this is done without you having to scale up media servers. So there's no reason that you need to start spinning up stun servers and turn servers and all that hard work. All of that is taken care of for you with the Amazon Chime SDK meeting service. And this is all pay as you go. So per attendee, per minute that is actively participating in the meeting. And that's the front end of the Amazon Chime SDK meetings. So this is how you build your UI that the customers and the patients, for instance, in a televisit, and the doctor will interface with. But on the back end, what we have is the ability to pipe that media from that meeting into things like transcribe. So I can take the media that is in that meeting and I can pipe it into transcribe or transcribe medical and get the information from that meeting in real time. So this is, a near real-time service where you're going to send the media out to the transcribe, we're going to pull it back, and you're going to provide that for you. Once we do that, we can add on things like translate. So we can take one of the 12 languages that the streaming transcribe supports, and now we can layer on translate. So a participant can listen in their own native language for greater accessibility. This is something that we have hooks in to transcribe for you, so you don't need to build that sort of the stream from something up to transcribe. And as transcribe adds new languages, we get those automatically built into the Chime SDK because we're using that service. So now we've taken the media and we've piped it into transcribe, we've turned it into translate, and we've put that back into the UI so that your customers can get access to that. Additionally, we have the ability using media capture pipelines to take the media and pipe that into an S3 bucket. So every 5 seconds, we put a media chunk into that S3 bucket. Every 5 seconds, we're continuously populating that for both the audio, the video, and the content share. So we're taking all of the information from that meeting and dumping it into an S3 bucket that you can now use. So one possible use case for this would be something like Amazon Recognition, where we can take a screen grab of the media as it's going on, send that out to Recognition, and get a label back from Recognition. And all of this is done without you having to create all of this hard work, this heavy plumbing to get media from your meeting out to Recognition. We're gonna do a lot of that hard work for you, and that's sort of the philosophy of the Chime SDK meeting. The Chime SDK messaging, as I mentioned before, is persistent messaging, and it's fine-grained control that a builder has to control who sends, who receives, and how they meet together in these channels. But on top of that, so we can fan this out to hundreds of thousands of receivers all at once, and using WebSockets to get that information out there. And as I mentioned, don't think of this as just as messaging, right? This is not just a channel like a Twitch chat or something like that. You can use this to pass data out. So telemetry data, what coordinates am I standing at? If you can get that information in, you can pass that information up to the Chime SDK messaging and propagate that out. One interesting aspect of this is that we have what are called the Amazon Chime SDK messaging workflows. And what the messaging workflows will let you do is, before that message is sent out from the sender to the receivers, you can process it. So we can do things like comprehend. So we can look for information in that. Are they using profanity that they shouldn't be using? We can filter on that. Are they passing sensitive information, PII? So like they type their social security number into the chat. We don't want to send that, and we don't ever want to send that out. So we can use this pre-processing to prevent that message from ever going out to the receivers. And again, we can get access to translate. As I had mentioned before in the Pinpoint, we can pass that message out to Pinpoint if we need to. Once we get that out and we send that out to the receivers, we can consume that for later use. So now we take that and we pipe that over to S3, and now we've got a storage of all of those chat messages that we can go back and search. So was somebody sharing confidential secrets in chat that they shouldn't have been? Well, we can go back into the history and look for that and find those instances because we've persisted this message and stored it for later use. as I had mentioned, the Amazon Chime voice connector is part of the PSTN services as one of the 3 pillars of the Chime SDK. And what this voice connector will let you do is pretty basic SIP trunking. So if you're at all familiar with SIP trunking, inbound, outbound telephony from the PSTN to a SIP-based SBC, PBX, something like that, a session border controller, contact center, things like that, you can go into either the console, so all of this is available within the Amazon Chime console, request a number, order a number, and you'll have that number delivered to you in a matter of seconds. You can put that number onto a voice connector, and now build the voice connector, now take an inbound call from the PSTN to that voice phone number and deliver it to a SIP target. We use internet-based endpoints for the Chime voice connector, but we support TLS and SRTP. So we have the security mechanisms to protect that SIP trunk from the voice connector down to your PBX. Additionally, we know how to allow list the IP addresses because they're very well-known IP addresses. So we should be able to work with your security teams to get that internet-facing trunk built between the voice connector and your SBC. And the good news is all of this is controllable by APIs. So if you want to spin up a voice connector trunk, it takes about 10 seconds with APIs. We have the code, it's well documented, and we can share that with you. In fact, I'll show you how that looks later. In addition to inbound, we can also do outbound. So this is outbound globally. We can make calls out to any number of countries, and it follows the same basic procedure as the inbound. We can get a number, we make that call out, and away you go. Again, all controllable by APIs. Where it gets interesting and where I get really excited about this is we can get really creative now, because now we can take, and instead of sending that out to the PSTN, we can send that call outbound to PSTN audio. And we'll talk about PSTN audio in just a minute, but think of it as that programmable voice. So I can take a call from my PBX, I can make that call out the voice connector to a PSTN audio service and manipulate that call. I can bridge it over to another number. I can play prompts. I can do all sorts of things with that. And I can do all of that with a SIP-based connection from your PBX, SBC, through the voice connector to the PSTN audio. There's one more scenario that we haven't talked on yet, which is the SIP-REC option. So what SIP-REC is a standards-based, RFC-based protocol that will allow you to make a fork media from an existing SBC, from an existing PBX, and send that out to us. So you're not sending us, it's not a two-way path. We're not responding and sending you any media. All you're doing is sending the media to us. So what that means is that you can take your existing SBC, your existing contact center, your existing PBX, fork the media off of there to a voice connector with SIP-REC and get access through Kinesis video streams to all of the great AWS AI ML stuff. So we can capture that media, we can send it up to the AWS services and get access to those and do some really interesting things. And we've got a demo for you a little bit later on about what that looks like. So I touched on the PSTN audio briefly. Let's dig a little deeper into that. So as I mentioned, there are two main entry points into a Chime PSTN audio service. So the first one is a PSTN phone. So we can register a phone just like we would with voice connector, and we associate that with the PSTN audio. Now we've got a call comes in, it lands on the PSTN audio, and we can answer it there. And additionally, we have the Amazon Chime voice connector that we can bring in. We can maintain SIP headers. We can, make that a pure SIP call. So if you want to send a diversion header, a user-to-user header, something like that, we can capture that on the Chime PSTN audio from your SBC. And this gets important later when we start talking about how do we correlate a call. How do I know that this call over here that has ended up over there that passed through a LexBot, how do I correlate that call between all of those different legs? And it's these SIP headers that will let me do that. So I take the call, I land the call on my Chime PSTN audio. Now what happens is it's an invocation and an action series between the PSTN audio and an associated Lambda. So the Lambda is associated with the PSTN audio. When something happens on the PSTN audio, so a new incoming call comes in, I invoke that Lambda with an event that says, I got a new incoming call. So this new incoming call has all the information, the calling number, the to number, all that other good info. The Lambda is then responsible for responding back to the SIP media application, to the PSTN audio with an action. What do I want to do? I want to call and bridge. I want to make this phone call into another phone number, or I want to play a prompt. Maybe I want to get some digits, so I can do that. So all of that is controlled between an invocation and action sequence between the PSTN audio and the Lambda. So what are some of these examples of things that I can do as actions? Well, for one, I can record this audio. So call comes in, I'm going to do something else with it. I'm going to call and bridge out to another phone number. I can, for the duration of that call, I can record that audio. Well, once we've recorded the audio, what can we do? We can send it to transcribe. And so we keep unlocking these things when we have access to these AI ML services. So now we've got it in a bucket. Now we can manipulate it. Now we can do cool things with it. Another thing I can do is I can play prompts with Poly. So I call in and I enter my account number and I want to respond back to that person and say, is your account number 12345? Well, I can create a Poly action that says play prompt 12345, and now I play that back to them. So I can verify things with Poly using custom prompts. This is also really interesting because it lets you, it enables you to move really fast, because now you don't have to get a voice recording for all of these prompts. Just recently launched, and this one is really exciting because of what it opens up to us, is the ability to take a phone call from, again, a PSTN phone number, from a voice connector, and send that call up to Lex. So Amazon Lex, if you're not familiar, is a natural language conversation bot. We can send this call up to Lex and get a response back from Lex with information collected from that Lex. We'll go deep into this one in a little bit because this one's really exciting and it's just launched. I've mentioned a few times the call and bridge action. So call and bridge action will let you make a phone call out to the PSTN. So I get a call in, I want to do something with it, I want to manipulate it, I want to apply some metric to it, then I send it out. So you can use this sort of a pass-through mechanism to get from A to Z with enhancements in the middle. As I talked earlier, all of these services work together. So I have Amazon Chime Voice Connector calling Amazon Chime PSTN audio service. Now I can bring that into an Amazon Chime SDK meeting. And all of these things work together. We're gonna show an example of the opposite direction of this, where Chime SDK meeting is going to make a call out into a PSTN number a little later. But the nice part is that these are all working together. They're all interconnected, and you can use them in really creative ways. And that's sort of one of my favorite things about the Chime PSTN audio is you have so much control over this call that you would never have had before, right? You're able to manipulate this call, you're able to send it in weird directions, terminate it, make a new call, do all sorts of things like that. So, as we've talked about, once we can get this media into an S3 bucket, that opens us up to many things. We can transcribe it, we can comprehend it, we can translate it. And so this option here, where we can do a post-call voice to text, so this is not real time, this is only after the call has ended, I can turn that voice into text. From there, I can do all sorts of things. Amazon Poly, as mentioned, will let you build these IVR menus, these responses dynamically. So I can read back somebody's name to them. I can build IVRs in multiple languages. So I don't necessarily have to go out and get a Spanish, a Chinese, Mandarin, English, voice actors, I can build all of those with Poly on the fly. Lex is definitely the real crown jewel of the recent launches because of what it unlocks. So as we mentioned, it is a natural language chatbot, and the thing is, we can build this in the console, in the Lex console. We have deployments that will help you build this Lex bot for you, and we can hook that in. We can hook it in from the PSTN. We can hook it in from a voice connector. And this means that you can take your existing contact center, your existing SBC, and add a Lex bot to it with very little effort and very little changes to your other environment. So we're not looking to go in and completely overhaul and replace everything that you've got. We just want to come in and add on to your existing deployment with an Amazon Lex. And if you've seen this Amazon Lex, we're going to get into this in a little bit. It's a really powerful way to capture information from the user to do things like deflection. So I don't need to send this call to an agent because I've already answered the customer's question, or I can intelligently route it. So I know that this person has an issue with their checking account. I need to send them to this phone number, not that main number. And so you can do all of these complex routing mechanisms with the combination of Lex, getting the information, and then the PSTN audio to do that intelligent routing. As I had mentioned before, when we talk about the call and bridge, it might sound, not too interesting, but with Amazon Voice Focus, you can dramatically improve the quality of the voice itself as it's passing through the PSTN audio. So Amazon Voice Focus is something that's been available on the Chime app for a long time. It's available on the Chime SDK as well, so the meetings component, and now it's available on PSTN audio. And what this will do is it will filter out that background noise for you. And I've done demos of this, and it is really staggering. I have had lawnmowers 10 feet away from my head that I could barely hear the people. Nobody knew that there was a lawnmower going on right next to me. It is a really, really powerful way. So you can imagine if I have agents in a noisy contact center, or if I have customers who happen to be driving a lot and they have a lot of background road noise. If you pass those through the PSTN audio with the voice focus, we can filter that out, make the agent's life easier, make it easier for them to understand and help their customer. So that's a mess. And that's intended to be a mess. This is the actual code that it takes to create a phone number using the APIs. What we've done is created a CDK construct that turns that into this. So Chime does not support CloudFormation, or CloudFormation does not support Chime, and CDK, the Cloud Development Kit. So what we've created is a construct for CDK that will allow you to use CDK and build with code your infrastructure. So if you need a phone number, we can get you a phone number. If you need a voice connector, there's similar code for the voice connector. And as you see in all the demos that we have here today, almost all of them use CDK. I happen to love CDK. I use CDK a lot because it's really easy to build with. And it lets you do things like this where you can look at this and recognize that this TypeScript says, give me a phone number in Illinois for SIP media application. And that's exactly what this does. So in the background, we're going out, and in the background, we do this, right? The background is there is a custom resource that is being run in a Lambda using Python to capture all and create this message for you. But you don't have to do that work. We've made it easier for you. So let's put those tools to use. So we've talked about a lot of different options that we have. What can we do with those and build an application and put all of that together? The first one I want to talk about is the Amazon Chime Lex bot. This one is created, this diagram here is a little simplified from what is actually deployed in the repository. So you can see here there is a AWS samples repository, and all these links will be in the presentation later, so don't worry. But what this is going to do is we're going to take a phone call in from the PSTN and deliver it to Amazon Chime PSTN audio. That naturally engages the Lambda associated with it, and we pass that call up to Lex. So I take the call, I send it to Lex. Lex does its thing, and we'll get into that in just a second. Lex can be associated with a Lambda, so I can enhance the Lex. I can do validations, I can do queries, I can do all sorts of things, anything you can do with a Lambda. Now Lex has access to that. And when that is complete within the Lex bot, I pass that back and I tear that segment down. So now I'm not engaged with Lex anymore. I'm gonna store the information that I gathered from Lex and put it in my DynamoDB. And so now I have it in my DynamoDB. Now what I'm gonna do is I'm gonna make another call out. So instead of ending the call and delivering it back to the PSTN, I'm going to send it down to a PBX. And this is using the call and bridging. So this is where we get into, we can be really, really creative with the PSTN audio because it's really just code. And what we can do with it is we have a lot of options. And I can deliver that to an SBC, to a PBX, and eventually to an agent and pass the information that I gathered in Lex to that agent. So I want to open a checking account. Great. Let's pass that information to the agent so the agent doesn't have to ask the person, what are you here for? They already know, it's popped up on the screen for them. So the other interesting part is some of these intents don't need to be sent down to the agent. So we can deflect that. So when it comes back from Lex, instead of sending it to the agent, we terminate the call and we've solved the customer's problem. They were calling in because they wanted to check their balance on their checking account. We've solved that. We don't need to engage the agent and save that agent that valuable talk time. So this is some more code, and I want to get into this, but a lot of this is just to show you just how easy it is to start a conversation bot. So this is my alias. I have an ARN that is associated with that. And after that, I'm really just asking it, what do I want to do? I want to say, how can I help you today? So when I make this call in, the LexBot answers, it says, how can I help you? And away we go. And as we talked about earlier, the concept of invocation and action, this is the action that gets returned to the SIP media application. I just have to say, all right, let's pass this information up to the Lex, and away we go. Actions equals start bot conversation action. So now I've landed this call into the LexBot. So what is a LexBot if you're not familiar? A LexBot typically contains languages, I'm using English US here, and intents. And so these intents are things that you can do within the LexBot to gather information, to solve a problem, to interact with the customer in a conversational manner. So I have transfer funds, I have open account, and I have check balance. We're going to look at the transfer funds utterances. So what an utterance is how do I engage that intent? So if I want to engage the transfer funds intent, I say, I want to transfer funds. That's great. I will go into that. At that point, now I'm going to start gathering that information. One cool thing about Lex is that you can invoke that intent with multiple slots already pre-populated. So I want to say, I want to transfer some amount to my checking account. Great, I've gathered two pieces of information. Now I don't need to gather those anymore. And this is where we get into the slots. So what is a slot? These are the things that I need to gather from the customer in order to fulfill this intent. I need to know the source account, the target account, and how much we want to transfer. Once I have all three of those, I'm done with this intent and I can move on. So what happens when I'm done is I return back to that PSTN audio the information that I gathered from those intents. So in this example, I wanted to open an account. My name is John. I want to open a checking account. All of this information gets passed back from the LexBot to the PSTN audio and is now available for more manipulation. So what do I do with it? Well, I'm going to store that information in a DynamoDB, and then I'm going to make this routing intelligent decision. So I'm going to say, oh, this is open account. That means I need to call an agent. Or if it's not, I know I need to disconnect it. And so I can process this intelligently and make these decisions based on the information that comes down from the LexBot. This is an example of just kind of that information that gets populated into here. we're going to query this information in just a second on the SIP media client. All of it already populated, gathered. We don't have to gather it again. This is an example of a SIP client that I built using some React components. So this SIP client is associated with an asterisk box. A lot of my demos use asterisk as a phone system. And what we're going to do is we're going to show you, we're going to make that phone call in. We're going to populate that Lex data right there so that the agent knows exactly what they need to talk about. Oh, hi, John. I see you're calling to open a checking account. I don't need to waste time checking and making sure what it is that they're trying to do. All of this that you've seen here is deployable via CDK that's in the repos that we're going to talk about. It takes about 10 minutes to get this up and ready, and you can see what it looks like to have a LexBot added to an SBC, to a PBX. I use asterisk, but you could use your existing PBX contact center for that. So that was a lot for the LexBot. We're going to shift gears a little bit to click to call. And this is one of those other ones we talked about where Amazon Chime SDK components work really well together. So in this case, I'm using 3 components, all of them, right? I'm using Chime SDK meetings, I'm using PSTN audio, and I'm using voice connector to take a WebRTC client. So imagine just a regular JavaScript page, a React page, an iOS app, an Android app. I'm going to put a button on that page, and it's going to start a phone call to a SIP agent on the far end. And so you can imagine that you have a customer and they need help. Well, you can route that intelligently through your PBX SBC down to your agent with information that you've already captured because you know who is pressing this button, and we can send it through that way. So let's get into a little bit of the details. I wanted to show this one because it shows a little bit just how simple it is to create a meeting with the Chime SDK. So this is a little bit more of a Chime SDK demo necessarily than it is a PSTN audio demo. So this is the React component that I built. This is the web page. Again, all deployable by you in a matter of minutes to get this up and running within your own account and have this ready for you. So what happens when I click the dial button? So when I click the dial button, what's going to happen is we're going to create a meeting. So this meeting is going to go out. It requires a client request token, a region, and external meeting ID. We're going to get that information. We're going to capture that information from this API call of create meeting. And we're going to take that and remember it. Then we're going to create some attendees. So we have to create a client attendee. That's the person on the UI. We have to create a phone attendee. That's the person that we're going to be calling. We're going to put these pieces of information together, package it all up, the meeting info and the attendee info, and pass it back to the UI. This is what that looked like when I pressed that dial button. So this is the handle dial out, is me pressing the button on the UI. And what happens is I make that call. So I make the call out to the API, and I get back that information. I get back the join info. So this join info is what I'm going to use in order to join this client into that meeting. So you can see here, await meeting manager join info, and await meeting manager start. And after that, I have established audio from this client through the Chime SDK meetings. And that's really all that it takes in order to set up a meeting. Now, this particular demo doesn't include video. You would need to build a video tile and some other components for controlling that. But simple audio, this is just about all that it takes. And you'll see it in the code if you take a look at that demo. At the same time that I'm creating that meeting and I'm joining that meeting from the client, I also have to make a call out to the PSTN. This is handled at the same time as before, and this is me going in here and doing this create SIP media application call. So I'm gonna take a meeting and I'm going to create a SIP media application call out. The interesting thing here is I'm able to pass in the SIP headers that user-to-user information. So I've retained the information from the meeting and I'm passing it down into the PBX. Now I can correlate this call from this user on the client to the phone call. Any information that I already know, I can correlate there. So that is a Amazon Chime click-to-call demo. Again, all available within the links that we'll provide at the end. You can get that one up and running in 10 minutes, and it's a really interesting way to do it. The Amazon Chime on-demand recordings, this one is maybe a little simpler, but it engages the Amazon Transcribe post-call analytics demo. The Amazon Transcribe post-call analytics demo takes all of the information from a phone call, and in this case, a caller to a callee, processes it and looks through it for all sorts of information, pauses, loudness of the speaker, and all sorts of things like that, presents it on a dashboard, and you've got access to it within, a couple seconds after the call has ended. So I created this demo, and the concept of it is sort of a journalist. So imagine a journalist wants to interview someone. So they have a phone number that is, I'm calling the source phone number within this demo. They call from that source phone number to the Chime PSTN audio. We then gather digits and make a phone call out to the person they want to interview. Great. Plays a prompt, says, hey, this is going to be recorded. Now I turn back control back to the caller. They can pause, they can stop, they can resume, all sorts of things like that. But because I have the intelligence of the PSTN audio, if they make a call back into that phone number, not from the journalist phone number, it routes directly to the journalist phone number instead. So I don't gather those digits. I can make this intelligent routing decision at that point to know I need to call the journalist. They have given out this number, not their own personal number, and now the person can call into that number without exposing the journalist's number to the world and everybody that they're interviewing, and still get that call and get it automatically recorded. They don't have to think about it. It's just done for them. So how does this work? This is that new call handler. And if you noticed, this is in Python. So because it's Lambda and the PSTN audio service doesn't really care, it just cares about Lambda, I can use just about any of these SDKs in order to interact with the PSTN audio from the Lambda. So before, I've shown some JavaScript ones. I like JavaScript. Now we're showing some Node. I love Node too. In this case, what we're going to look at is who is making this call. Is this call coming from my source phone number? It is. Great. We'll respond back with this play audio and get digits action. If not, I'm going to play a message. I'm going to say this call is being recorded. Hang on, I'm going to connect you, and I'm going to do the call and bridge. So different actions depending on who is making this phone call. This is sort of the power of that PSTN audio, where you can be really you can be really creative with what you do with these phone calls that you normally wouldn't be. So great, we've got the call. Now what we're going to do is we're going to send an action back once the call has been established that says, hey, let's start recording. So all we have to do is take this call. We're going to send it to an S3 bucket that we've already provisioned. We're going to dump it in a prefix, original audio, and we're going to pick that information up on the transcribe post-call analytics once this call has completed. So that was post-call analytics. Now what we're going to talk about is live call analytics. This one's interesting too. So what we can do with the live call analytics is we can take an existing contact center. We can take your PBX, your existing telephony provider. We don't need to come in and replace your existing trunks. You send us a forked SIP-REC from that PSTN, from that SBC, up to the voice connector. We're going to pipe that over to Amazon Kinesis video streams. Just the audio, it says video, but it's actually just the RTP from that call. And we're going to create a stream of RTP. What this stream of RTP is going to do is we're going to consume that on a Fargate. So we have a Fargate consumer that we've built. Doesn't have to be Fargate. EKS, ECS, EC2, chaining lambdas, doesn't really matter. The demo example currently builds Fargate. I believe it's going to be Lambda soon. We're gonna consume that RTP stream. And what we do with it from there is we can send that over to transcribe. So now we've taken the call, you've forked the media up from SIP-REC up to the voice connector. We're going to take that and we're going to send it to transcribe. We're also dumping it to an S3 bucket just to save it for later as well. And now we can take that and comprehend it. So we can get sentiment analysis. Is the caller angry? Is the caller happy? Is the caller getting angrier or getting happier? And we can pass all that information back to the agent. We can pass it back to supervisors. We can do all sorts of triggering on that because we know what's going on in this call in real time. So this is what the dashboard looks like. You can see a series of phone calls. Again, all built for you. This is a CloudFormation one-click deploy. Takes about 10 minutes to deploy, but you'll have all of this built in your own environment for you. And you can see that we have a call that came in and the caller was not happy. And you can see that some of them went down and some of them went up. What does this look like in real time? This is one existing call that is going on. And you can see here a turn-by-turn response from the call. So the caller starts and says, okay, perfect. And then the caller responds and we're going back and forth. All of this information presented either to the agent, to a supervisor, we're getting that information back in near real time, matter of seconds from when it was spoken to when it can pop onto their screen. Additionally, we have the ability to play that recording so we can go back and review old calls to see what happened on this call. Almost immediately after the call has ended, we have this recording available to you. So this is the Communication Developer Services. There's a lot here. They're really interesting, and you can be really creative with how you use these together. But hopefully they'll help you build faster and build securely, and use your existing applications and enhance those with these services. These are the links. These will be available in the PowerPoint demonstration. The workshop is really interesting. There's two of them. There's one to build a Chime SDK meeting. So you can go through and just step by step by step. If you haven't done a workshop before, the workshops are great. It's a great platform to go through and kind of learn something from scratch. There's one for Chime SDK meetings, and there's another one for PSTN audio. So go through those, take a look at them. They're really, really good. The GitHub repos, these are those 4 demos that we talked about, the PSTN audio with Lex, the click-to-call, and the on-demand recording. Some of these are just been updated and revised, and then the transcribed live call analytics. The on-demand recording also links out to the post-call analytics. So if you're looking for the post-call analytics, that's embedded in the on-demand recording. If you're interested in the CDK constructs, the CDK constructs information is available out on the CDK Labs repo. Would love you to contribute. All these are open source projects, so feel free to come in, open a ticket, open an issue, open a pull request. We'd love to get you involved in some of these. This is my contact information. I'll be available at the back of the room or outside right afterwards if there's any questions that anybody has, but feel free to reach out to me on any of these. GitHub, Twitter, probably the best. I tend to see those the first, but yeah, feel free to reach out with any questions about how you can incorporate Chime SDK into your applications. Just a quick note, take a look at the certificates and training for Skill Builder. I have learned a ton from certificate training. So I've gotten quite a few certificates here recently, and they are really, really, I've enjoyed taking them. I know it sounds a little strange to enjoy taking tests, but I enjoy taking tests, and I've learned a lot from taking these tests. So be sure to take a look at that. And with that, thanks, and be sure to complete the session survey.